welcome to Objective 2 for Module 5. So this is the last of the videos for this module that I'm going to be recording. And the reason for that is because the other objectives only have like one slide and they point you to a web page. So make sure you go to the web page and check it out. And most of it's teaching you how to use field maps, which is the system that we can use to collect data for ArcGIS online. So check those out and go through those in detail, like the web page, and think about some of the exercises. So this last objective, we're going to talk about the steps to having a successful data collection using a GPS system. So there's 5 stages, and so we're going to go through each of them. And these 5 stages are defining the project mission, determining the best time to collect GPS data, selecting an appropriate GPS grade, specify which features and attributes should be collected, and then actually going out and collecting it. So you can see that there's a lot more to it than just running out there with your handheld just to pick up data. So the first step is defining the project mission. So you need to know what is the scope of what I'm collecting. And often that is the hardest part, right? Like, why am I going out and collecting data? And what do I need to collect data for? So for example, it says here how much data should be collected for each feature. So what attributes do you need? What kind of accuracy do you need for each of those? You need to know all of that. You also need to know the timeline because things can change over time. And you could spend hours and hours and hours out there, but you may not need to be out there. You may only need to generalize a certain feature or features, and you can collect the data faster. You need to define what staff you need and any other resources and any other local variables. So perhaps like, if when you're going to go out there, do I need to know what's there already using a raster, or is there anything else that I need to be aware of, such as a cliff that I might fall off of, one of those. And then, like I mentioned, accuracy. What accuracy do you actually need for it versus what is effective, right, and efficient? The second step is to go out and collect the GPS data, or find the best time, I should say. So to determine the configuration of the Navstar system, which affects our DOP values. So you want the lowest DOP value that you can find with the highest amount of satellite availability. So usually those two kind of go hand in hand, but you can go online and check it out. There is a page with Trimble, which I'll give you in your assignment, and you can go there and you can check out, what satellites are going to be available when I go out at the time, or can I choose the time so that I'm more efficient with my data collection. So we also need to worry about the orientation, which is DOP value, and then other information. So, maybe I might choose a different location because the orientation is going to be really bad. Maybe I need to go to that particular area. So what time is the best time? So I've already kind of gone through these a little bit, but I'm going to try to go again here. So with satellite availability, you need to make sure you have a minimum of 4 satellites. I know most of the stuff that we are doing in this class, we don't necessarily need elevation, but if you have a minimum of 4 satellites, then you know that you're getting all the details that you need with the best precision you can get. And then we have the satellite orientation. So we talked about DOP values. So the geometry affects that accuracy of the location. And if you have unfavorable orientation, you'll end up with less accurate answers, even if the satellite distance and location data is really good. So that geometry is really, really important. Those DOP values are essential. You can also apply an elevation mask. So you need to take into account the terrain. So for example, if you have trees, lots of trees, you might need to not take any satellites that are going between trees. We always apply an elevation mask of like 10 to 15 degrees anyways, so that we get rid of the lower horizon. But if you are working in a city or a forest, you might want to have a higher mask so that you get a better estimate as to the best time to collect that data based on the information that you could possibly receive based on that mask. Then we need to decide what GPS system do I need. So things to keep in mind is budget, time, the quality, so the accuracy and precision, the expertise you need to be able to run it, and just other project requirements. Like, so are you going to have to go rent a survey quality GPS, or can you just use your cell phone? Then we need to specify which features and attributes need to be collected. So this is really important when you go out to collect the data, because you don't want to go out there and collect too much because you could be out there for too long, but you also don't want to go out there and have to go back out again and to try to collect that information. So for example, the feature data is your locational data and the type of data it is, so like points, lines, and polygons. So a good example is fire hydrants, road centers, signposts, park boundaries, legal lot boundaries, tree locations, stuff like that. Then you also want to know which attribute data you want to collect, and that is what is the feature and describe it. So for example, what is the type of sign? What is the color of the fire hydrant? What's the type of road, and what markings does that road have on it? So those pieces of information can be really, really important. And so making sure you know what you need for the purpose of your scope needs to be defined before you get out there, not while you're out there. You can adjust it while you're out there if you suddenly realize something out there is really important and you didn't have it in mind and you forgot, like just noticed it would work much better. But overall, this should be planned before you go out there. So this is where the data dictionary comes into play. So in your one assignment, the assignment 2, I think, it had a data dictionary. So what a data dictionary does is it lists the type of data, so both for features and attributes, that need to be collected and the format in which the data should be collected. Then the parameters, you need to know what the parameters are. You know, is it going to have any limitations? Is it having classes? So do you need to implement domains before you go out there? And then any planning software that you do have, you can design a data dictionary, and then that can just take the form of some sort of menu. If you don't have a planning software, then you can make up a table and just write it in there, and then that allows for the people collecting the data to see what they need to do. The next one is field notes. This is so important, so important. If you go out and do any kind of GPS data, you should always have field notes. And it might be like, well, you know, I can get it all into my system here. Why do I need field notes? The thing is that field notes are legally binding. What you collect and put into the web page is not legally binding. So you need a pencil and paper, which is so, I know it sounds retro, but you really need something that you can use that's legally binding. Use care with what you're collecting. Even though you're using a pencil, do not use an eraser. The reason you would use pencil is because if it gets wet, it doesn't run like a pen, but a pencil is not meant to be erased. Cross it out and write above it, or cross out the whole page and redo it if you have to. Never erase, because it's a legally binding document. And also it allows for you to expand on it. So if you have field notes already, you have everything you need, then you can keep adding to it. And field notes can include just like what feature did you pick up. You can put in the coordinates. You can just have a little table set up, some of the attributes, and a sketch. A sketch is really important, right? Like even though the data might show up on a map, that field sketch is going to be that legally binding document. So always draw out the area. Then the last step is collecting data. So you go out and you use some sort of field collector that has a receiver, an antenna, and some way to log data. And then you go out and actually collect those features. This is the easiest part. It really is. You need to have good planning, and you need to have an appropriate device, which again probably makes sense. When you go out in the field, make sure that you put your receiver right above that item. So if it's a fire hydrant, put it on top of the fire hydrant, right on the very top, tippity top of it, along the center line. Do not do it beside. If you have to do it beside, make sure you write down the offset in your field notes, so then you can adjust the direction it's supposed to go. For example, building corners, you're going to put it right beside there. Building corners are tough because you end up with multipath. A tree, if you have to go under the canopy, you might lose signal. So you might have to offset it and make sure you measure it out. Use a measuring tape. And that will, then you can put that in your field notes and say, hey, this is off by this much. So when you come back into the the office and to do your actual map, all you need to do is edit that point over. So in summary, if you're going to go out and collect data, you're going to define the mission. You're going to figure out the best time using any of the almanacs that are available that are online. You're going to select an appropriate GPS device. Then you're going to decide what features and attributes you need to collect so that you're not out there forever, but you're also not missing any data that's required. And then finally, you will go out and actually collect the data. So there's no real required readings. You'll get to do this for assignment 3. And I look forward to seeing what you guys give me for assignment 3.